Hello. So today I will be presenting the solution we built on top of Algorand. I will be showing this in three parts, initially starting with the problem statement and solution approach, moving forward with the demo, and finally ending with the future roadmap. So the problem statement. Let's say Katy Perry is planning a concert. So we will be having an organizer who will be managing the entire logistic, ticket management, and the entire supply chain of it. So in the ticketing space, we see around 30 to 50% of tickets are held by originators, promoters, producers, fan clubs, employees, and friends. Remaining tickets are sold on ticket selling platform, and there can be multiple ticket selling platforms depending on different jurisdiction and geography. Some of the examples are Ticketmaster, Eventbrite, BookMyShow. Most of these tickets are sold in advance, and which can lead to change in plan at the end, which can thereby lead to ticket reselling. In the entire ecosystem, we have three problems: ticket fraud, ticket counterfeiting, and ticket touting. So how we are trying to solve this problem? So we are making use of two things of blockchain. One is non-fungible token, second is smart contract. So we are using non-fungible tokens in the form of tickets. So whenever a ticket is created at the originator, all these tickets are held on blockchain in form of non-fungible token, so that entire life cycle of the ticket can be easily managed, which can take off. Which can take off the ticket counterfeiting, ticket touting problem for us. Secondly, we are taking off all the complexity from the secondary platforms and from the attendees in this case by storing and managing the keys on our own end, so that no one can know the complexity of the system and can easily easily integrate it with the existing platform. So let me give you a use case. So we have an organizer in this case. Let's say she is creating 100 tickets for the Katy Perry concert. It's a small concert, let's say. So these 100 tickets are created as an NFT on top of Algorand blockchain. So this gives us few use cases. We have a decentralized ticket supply chain. It can be easy, the tickets can be easily validated, helping against ticket counterfeiting. It provides an ecosystem for ticket reselling, enabling standards depending on local regulations. And these are non-fungible assets in the form of tickets with allocation from originators. So these tickets are eventually held on blockchain, on Algorand blockchain. Here we have the distribution manager, the channel manager. This channel manager will be connecting with Algorand, will be connecting with secondary marketplace, and will be giving API as a service for the secondary marketplace and all the consumer apps in general. The part of holding the account addresses, private keys, private keys for the secondary markets, and the consumer is also done by the distribution manager, where it makes use of Vault to store all these account addresses and the keys, and does the computation depending on the use case. So here we can totally manage the complexity without consumer knowing or understanding whether it's dealing with blockchain or not. And secondly, it can get the use of, like it can know whatever it's dealing with are genuine and easily traceable in the entire life cycle. So first of all, I'll go with the demo and then we'll come back to the presentation. So here we have, I have created these as an API for the start, which can be integrated in any app or any marketplace in general. So we have the connecting, which is we are enabling uh, login or sign up using four different mechanisms. One is Google log sign in, Apple sign in, Facebook sign in, and normal mobile sign in. So these four things we have in general. And whenever a new user signs up on our account, either using the marketplace or the consumer app, we create we create their account address. So we get we get a user ID for that user. For each user, we create the account address, the security paraphrase, like we create the wallet for, we create the account for a user on top of blockchain and manage it in a database for now. We are in current process of moving this entire thing on Vault so that it can bring in more security for the consumer. Okay, so let us create our event in this case and see how it is created on blockchain and how the entire life cycle is working. So let me start by creating a concert with called Katy Perry in this case, having the event description. It is all API as a service, so you can have date, title, description. Let's in our case, let's create 5 tickets for now, and the event pricing, let's make it $180. And yes, so let's see. So let me create this event. And as I can see, I got an instant response in this case. The user, for the organizer, it's so fast, it's so convenient. They got the result immediately saying the event ID 10 is created in this case. And if I go into my database, or if I go into my database, and I can see I have created a public event ID 10 with all the details of Katy Perry. And you can see there are few more things. We have something called temporary address and temporary security paraphrase. So, so at this time for consumer, they got the output fast. However, if we see on the back end, is still doing a lot of work. It is creating all these tickets as NFT on top of Algorand. How it is doing is, so these temporary addresses, what is the use of these temporary address? As one account address can only create 1000 tickets as a limitation currently. So so to scale the system so that one organizer should not be overwhelmed if it's creating more than 1000 tickets. So these temporary address can manage multiple creation of those tickets. And once those tickets are created, it sends it to the organizer's address. So it is doing the opt-in as you are seeing, and then sending those tickets in the account address of the organizer. So this is my organizer, and it received it, or it has created all those tickets. So it holds all those 8 NFTs in its wallet, or in its account address. And those records for public event 10 are also stored in a database which manages. So if you can see in this, as those tickets are being created, these are the asset IDs which are created for the public event ID 10. We have the business user ID, which is the organizer user ID called 47, and the current holder is also 47. So this is the creation part, where the creation is smooth, and user, consumer, or these marketplace, secondary marketplace need not to know about blockchain. Everything is managed on on our end. We do the signature, publishing, everything on our own end. So you can see all these tickets are currently held in this wallet, in this account address. So let me move to a like to a next life cycle in this case. So here, so this is an API to get all the events. Let's say for the user ID 47, because that's what my 47 was, a user ID in this case. So I can see all those tickets are created. Initially, this is from the previous ones, but as you scroll down, you can see we have this Katy Perry's concert also created, and all those ticket IDs are held in the organizer's account. So now let's say someone's need to buy those tickets. Like, since it's a open public API, everyone has an access to the events. So let's say some user wants to buy for public event ID 10, and let's say 32 is a user ID, which is currently one of the user in our records. So this 32 user with account address this is needs to buy a ticket, let's say. So Currently, this is all it's holding, all it's holding. So this user wants to buy a ticket for Katy Perry's event. We have like all those GWT tokens and all in here for security. So this point of time, it's a bit slow request because since it is for one ticket end to end, it is waiting until the entire and until the ticket is created. So what is happening is this user is giving consent, saying I need to opt in. I'm agreeing on buying the ticket, and once the opt-in is complete, the money is received, the user or the organizer sends the money, sends the ticket in the in the in the account of the buyer in this case. So as we can see, we receive this ticket in here. So let me see. The asset ID is 299140. So and then the same ticket must have moved from the originator's account. So 299140, and we are managing it in a database as well. So for 299140, it was currently hold of 47. Now it's hold by 32, and the originator was 47, and it's an active state. So this is how it's being done. So I showed you the buy flow. I showed you the create flow. Now let me show you the resell flow when someone wants to resell it. Let's say this 32 user says, I don't want to go anymore. I have changed my plan and I need to resell the tickets. So whatever marketplace you might have bought it, let's say you might have bought it on Ticketmaster, you can sell it on any other platform because the entire life cycle record is managed in the blockchain, and with this distribution manager it connects to the entirety of it. However, you need to hold the right credentials for it. So let's say for this uh, the 32 user, this particular ticket which it was holding, it wants to sell it, it wants to put it on resale. So the 49 uh, ticket ID, the user wants to put it on resale, and it wants the price. So it bought it off for 80 pound for 180 pounds, and it want to resell for 120, let's say, or make it 150 in a case. So this dynamic pricing can also be managed because there are a lot of cases like in Ticketmaster, there are bots who buy a ticket instantly and then resell it on the same platform for a higher price. So those kind of things can also be managed with us. We can identify the bot activities, which I'll go later on, and then we can have those restrictions on price also, because so that you could not have those malicious activities on a platform. So this 32 user is saying, I wanted to put this ticket on resale for 49 for $150. So this ticket was in active state. Now if I refresh it, it is now in resale state. So once it is in resale, so once ticket is available for resale, it can be bought by anyone. So let's say uh, we have other few more resale tickets. So this is a resale ticket 51. Let's say we are trying to buy it. This user 45 is trying to buy it. So once uh, it sends its request, does payment and everything, it will be going through the same flow, doing the opt-in. When the money is received, the ticket or the asset is transferred from the current holder's account to the buyer's account. So in this case, as we see, we received an opt-in initial, that this user did an opt-in, and then it received an asset called 299144. And this user was 45 in my case. So for 299,144, current user is 47. If I refresh it, it becomes 45. And yes, so this resell thing is also done. So I have shown you few use cases like create, buy. You can put a ticket on resell and then buy the resell tickets. Same way there are other use case like send and few more. In like one is send for now. So this is what the demo is. So coming back to the presentation, yes. So as I was talking about the the bot activities. As we have seen with Ticketmaster, they are bots who buys most of those tickets instantly and then puts those tickets back on the platform for a higher price. So what we, so this is again a future work which we are currently working on, uh, which will be coming up soon. So what we are trying to do is all these account address, since all these account address holds these asset. So and to whom it is transferring to, from what address it is receiving. So we are attaching a credit score or a credit score to each address. This can be utilized for two cases in our scenario. One is faster payout to the organizer or to the secondary marketplace in this case, because as the rating is higher for the for the address, we trust that address more. In the same case, if some address is trying to do multiple buying and putting it on resale for higher price or whatever, it's a malicious activity can be going on. So we can reduce the credit score first of all for that thing, and second thing, we are making use of clawback address in this case. Each asset which is created initially, we have attached eventers address as the clawback address. So later on, if we find any malicious activity going on, we have a power to clawback that asset, and it can be easily done. So this is currently we are working on. It's one of the future work. So yes, so why now? It's because of the speed of blockchain. It's giving us transparent, it's giving the transparency approach to the solution, and it can be deployed on scale. So this is the roadmap in general for eventers. However, for the for the blockchain front, for this particular solution, we are currently working on Vault, where we can uh, where we are putting all those assets, or also where we are handling all those tickets, sorry, all those keys in the vault and applying all those operations operations on the vault for now, so that all the keys are stored as it is in a secluded environment, and only the operations can get in, and no one has access to the keys eventually. So this is one thing, and second thing is the credit score thing, where we are attaching the credit rating to each account address, and depending on the malicious activity and so on, we can claw back the asset in that case. So this is the team. So it's me, Akshay. We have Vivek, who helped us in the design of database part of it. Nisha, who is assisting us in the machine learning part of it, where uh, putting the credit rating on each address, and Vikas, who is helping with the Golang implementation of it. So yes, uh, this is what our demo and the use cases. Here is our wiki, which shows how the Connect API is working, how you can create all those things, how we are going with the blockchain flow. So everything in terms of details through API request response and how it is working is being totally written out here. And this is the code base which we are currently working on. So definitely you can have a look and get back to us with any questions you like. So yes, thank you.